And now for something completely different, so they say. Or the other title for this could be Confessions of Somebody Who Really, Really Ought to Know Better by Now. Me, because I'm not exactly a newcomer to doing this sort of thing. Well, the engineering, not the speaking with PowerPoint. So we had about a month or so ago a server get compromised. Well, this kind of happens day in, day out. This is not really rocket science. And this happened to be down at our office in Sussex, where we have, for various reasons I won't bore you with, a few customer machines as well. And it generated a gig of traffic and tried to ram it down a link that was slower than a gig. So far, so good. It then went off the rails a bit. Because I started debugging this, and became fixated on the fact that clearly the problem was this link. The only snag was there was nothing wrong with it. Well, there kind of was. There was some server trying to ram way too much data down it, but the actual link itself was going, yeah, I can cope with that. So why did I end up in this bizarre place? Confirmation bias. The human brain is really, really, really bad sometimes at taking a step back. So when we first saw a problem, I'm sort of looking around going, oh yeah, this looks all right, this looks all right. And I rebooted a router at the far end of the link, and the problem went away for about 10 hours. Presumably this is because the DOS attacking software got somewhat bored or lost its way or whatever, but whatever, knocking it out made the problem go away. So I'm then going, well, hang on a minute, I bounced the far end of this line. So clearly that's where the problem is. And this was made 100 times worse, again for reasons that I won't bore you with today, was that this line was effectively a single point of failure. So whilst we could swap the kit at both ends, we could reroute, we could do all sorts of things, but we couldn't swap out this one connection between A and B. And I'll come back to that because there were some things with the way this was provisioned that, again, made it much worse. Once you end up being committed to thinking that this problem is this chair, it doesn't matter how much common sense or your colleagues or anything else may be waving a big banner in front of you, you will manage to fit every bit of evidence that you find to your pet theory that here is the problem and I'm solving it. And you don't realise you've got here either. So it's a bit like sometimes you're reading through air accident reports and things, and you go, well, how on earth did they manage to do that? Everybody can see that this was a stupid chain of events. Well, I can tell you, having now been there, probably for the first time in a long time, it's actually really, really easy. And it gets worse because your colleagues think, well, this guy knows what he's talking about. Hell, there's people in the room who pay me to do this to their networks. Well, not break them. But he must have seen something we haven't seen. So that can make it even worse. So what did we take away from this? Number one, it's not always the telco's fault. And Neil did not pay me to say this. Despite the fact that they were in the frame for nearly 24 hours, BT were very, very well, and they were fantastic, but, but there was nothing wrong with their tail on the circuit. And this is a circuit that's delivered by another provider with a BT tail. And it's not always your service provider's fault either. And the other thing we learnt is that when you start coming up with really, really, really way out failure scenarios, and I discussed this with somebody in this room, and we were both earnestly thinking, this could definitely be our problem. There's a laser somewhere that's overheating. It's time to take a check, have a cup of tea, and think, hang on a minute, this is truly, truly bizarre. By the way, I'm quite sure that somewhere there has been an outage caused by an SFP overheating, but let's not go there today. The other key thing is, in this instance, what made this far worse is because we had something that naturally makes us jumpy, we have had for a short period of time a point of failure in the network, you automatically assume it's got to be that, mainly because you've got no real way of checking that. As it happens, we failed all the traffic over to a stacked up set of ADSL lines, and they behaved in exactly the same way. But obviously that was a problem with the broadband circuits as well as this perfectly functioning line. So how do you debug the engineer? Because that's even harder than debugging the network. Well, it's really boring. You've got to take a really structured, first principled, methodical approach to what you're doing. And listen to your colleagues. And equally, if you see a colleague who is getting stuck in this tar pit of hell, speak up. It doesn't matter if it's the CTO that's doing it and you've only been working there for a week. They really will appreciate it and they'll be buying the beers later. Because at the end of the day, you've helped fix the problem. And ask yourself the question, is it really, really probable that all of these weird things that I've managed to make fit this scenario, are they really all going wrong at once? It's unlikely. Again, trust your instruments and your instrumentation. One of the problems that we were having was that the affected server was in a part of the network that was for testing purposes only, so wasn't properly being monitored. However, there was something monitoring the far end of this line, but it was being monitored from the remote end. So, of course, those SNMP packets, they weren't really doing very well on a line that was already oversubscribed about threefold. But there's a tiny fragment of a graph that shows about 800 megabits a second for maybe 10 or 15 minutes. And we looked at that, or I looked at that and went, oh, that's completely wrong, the line can't take that. No, it can't, but that's what the router at the far end was trying to shove down it. Beware of hidden gotchas. So the way this line was delivered to us is that it is handed off as a 1 gig circuit at both ends, and it is rate limited by our provider on their optical gear in the middle. What we now know, and their NOC knows, and a lot of discussions have surrounded this, is that when that optical gear goes, oh, I've got a whole load of stuff that I've got to rate shape down, it wasn't showing any of that as discarded packets. So they weren't seeing a huge number of discards. No errors, no discards, no problem. And because of the way that the line would come up, OSPF would re-establish, a default route would make it, traffic would start hammering, oh God, there go all my OSPF packets, falls down. The way this was happening over the 5-minute period meant that when they looked at the traffic that we were sending, they went, oh, you're running it at maybe 60, 70% capacity, so they didn't alert, oh, by the way, you're maxing this thing out. So you've got really scary things like that that can be going on without you realising it. So you have to trust your own instruments and not somebody else's. And finally, beware of quick fixes that you put in late at night whilst you're tired to try and fix another problem, because the original compromised server was exactly this. It was we need to get this customer onto a machine of their own because there was some Joomla vulnerability or something. So we got something in a bit quick, and yeah, the Joomla vulnerability, it showed up. When will people learn not to just take what is put in an HTTP GET request and pass it straight to their database? I've stunned you all into silence. Excellent. Does anybody wish me to embarrass myself any more with questions? Oh, you're being kind. You're too kind. No, the whole point of this was to say this can happen to any of us, and it does, and when it does, be nice to your colleagues, because one day you might be up here having to admit to it. So thank you for listening and not heckling too much. And with that, I shall pass you on to the next person.